I want to give you a little bit of a tutorial on how to create a new database inside of DataGrip. This is one way that you could create databases for your project. So I've got a variety of connections already established here. I'm just going to connect to a Postgres database server that I'm running on my laptop, and that's in this Notebook connection already. So you've already got a connection, you've already got a database of your own, but I'm going to just kind of start from scratch here to show you how this would fall out. So here I'm going to just say create a new database, and I'm going to just call it my new DB. You can see one of the things that DataGrip does while you're using it in these wizard kind of windows is it gives you a preview of the actual SQL that it's going to generate and then execute against your database, which is kind of instructive. Not necessarily something you have to learn, but it's good to get familiar with those underlying commands eventually. So this is going to create a new database. You can see that it's now showing up in this list. One of the things that Postgres does when it's organizing databases is it allows you to have what are called separate schemas, and this is kind of a namespace within which a particular group of tables is going to be created. And the default schema is called public. Now you can create additional schemas if you wanted to segment your database into several parts, like for example if you wanted to have a human resources schema and a financials schema and a manufacturing schema in order to kind of segment the different portions of your database into larger groups. You can certainly do that. The default one again is called public, and I'm just going to use that. If I wanted to create more schemas, I could come in here and say new and then enter new schema and create a new one, and then I could build tables inside of that. But we're just going to stick with the public one here, and you can see here when I drill into this, it's empty. There's no tables defined within it. And so what we need to do is create one. And I'm just going to do a simple kind of product order customer scheme here, sort of a generic example, but it should illustrate the various features of using DataGrip to create schemas. So I'm going to first of all create a table, and I'm going to make this a little bit larger here so we can see more what's going on. Let's make this be our customer table. So I'll call it customer. You can put in a comment, people who buy stuff. And you can see down here at the bottom, it's also showing us the SQL that it's going to execute against the database, which is kind of convenient. Again, if you're trying to learn how this works under the covers, this is a good way to do it. Currently, I have no columns, and I want to add some. So I hit the plus button down here, and let's start out by adding a key field for this table. So I'm going to make a primary key field, and I like to just call these things ID. That's simple and convenient. It's an integer type because it's just going to be a sequence number that's created for me by the database. And what I'm going to do then is I'm going to select here this auto inc. That basically says make this thing something that's going to be automatically incremented every time we add a new row to this table in the database. And the type for that is called serial in Postgres. It's different in different databases, and that's another great thing about using a tool like DataGrip that's database independent or cross database, is you just have to basically say, hey, I want this to be independent, or I want this to be auto-incrementing, and then DataGrip knows how to tell Postgres to do that. I'm also going to indicate that this is the primary key for this table, because DataGrip can then make use of that to figure out how foreign keys are going to relate to it and that kind of stuff. And you can see that in addition to just declaring this column ID, it's now added a constraint. And constraints are things like primary keys and foreign keys and check constraints, and there's a whole variety of them. But it's creating a constraint called customer PK, and it's generated that name for us from the name of our table and PK for primary key, and then it's saying this is our primary key. So that's good so far. Let's add, say, first name, and let's make this let's do how about a string? No, we're going to make this a varchar. Now what's a varchar? Well, there's two kinds of fields that are normally used in a database to store strings. One is called the char field. We could start with that and say char. And then normally what you do with a char field is you say, here's the maximum number of characters that we are going to be able to store in this field. So I could say like 40 characters should be plenty for most people's first names. The challenge with a char is that no matter how many characters you actually store in there, it's going to be allocated 40 characters in the file on disk where the database is stored. So a more efficient way of doing this is called a varchar, which is a variable character field. And this will store up to 40 characters, but if you put fewer in there, it won't actually allocate extra space on disk. So that's normally what I will use for a field that contains a string. Now I don't need to say anything about auto-incrementing or primary keys. However, I can use this checkbox to indicate that this is a required field. So if the business rules behind this application that we're building require that I have a first name anytime I put in a new customer, I can indicate that by saying, hey, this can't be null. So I can check the not null there. That's going to require a first name whenever I add something to this table. And you can see down here in the SQL that's being written, I've got this first name field. It's a varchar 40, and it can't be null. It has to have a value. And then we'll add another field called last name. Same deal, say varchar 40, and I'll make that not null as well. And then let's just, for yucks, add an email address. We'll make this a varchar 80, just to show you can use different sizes, and make that also not null because we assume that we are going to be able to email our customers. And then I am set. Now you can see that it gives us this summary information here about the fields that we've defined so far in this table. We can also see in this keys tab that the customer PK is the name of our primary key field, and it is the ID field in the customer table. So this is just a way to see those keys. We haven't defined any indices or any foreign keys in this table yet, so that's all good. We've got the fields that we need for the customer. And you can again see the overall SQL script that's been created for this constructing this new table, create table. And then when you're ready to go ahead and add this to your database, you can do a couple of different things. You can just go ahead and execute it. That's the default case. Or you can also open up this query in an editor if you want to tweak it for some reason. But when you're using a wizard like this, it's probably just as simple to just go ahead and execute it. So we'll run that. And then we can see right away it shows up here in our hierarchy of tables underneath our MyNewDB database. And then those are the fields that we just added. We can go back and edit those things, change them in different operations as we change the shape of our schema. But we're going to, for the time being, just skip that. So now I'm going to create another table, and I'm going to make this one be a product table. So another table, and I'll call this one product, things customers can buy. And then this is going to feel very similar to what I did before. I'm going to create a synthetic primary key, just call it ID. It's an integer. I'm going to make it primary key, and I'm going to make it auto-incrementing like I did before. And then I'm going to add a new column. Let's call this name, and we'll make this a varchar 120. We always want to have a name, so we'll make that not null. And then we'll add a description, and I'm going to make this I'm going to call this text. Now, a varchar is a kind of a fixed maximum field. So char is a fixed length field that's always going to be used. Varchar has a maximum length that could be up to that long. Text is another type that's designed to contain a larger amount of text, so a complete catalog description in this case. Some databases will make those text fields searchable and some other helpful things. So we'll use a text as the type and also mark this not null because I want to be sure that descriptions get added to our product information, and then we'll go ahead and execute that, and we can see that it adds the product table to our database. Let's go ahead and, just for yucks here, let's add some customers. So we can do that by just double clicking on the column, or excuse me, on the table name, and then going up here and hitting add new row. And I can come in here, and of course Fred is going to shop at our store. Okay, now notice I haven't put in a value for the ID. I could, but because I've already made the ID field be something that's going to be auto-incremented by the database, all I've got to do is save this field out. And we do that after we've typed in things here in this little spreadsheet-like thing by pushing the submit button or the up arrow into the database. You can see that because the database has automatically assigned an ID, we just get that value here as a unique ID and don't have to monkey with it ourselves. And let's add a couple of more. So Zelda, Ziffle, Zelda, whoops. Zelda at example.com, say. And then we'll add one more. Let's put in Ferris wheel round at example.com. And then we'll upload those to the database. And again, we get the IDs assigned automatically. And we can also add some products to our database here so we can do some testing. So again, the ID is generated automatically. And let's call this widget helpful thingy. Add another one. Call this a doodad. Must have home thing. And another one. Call this a gimcrack. Clever Bob. Okay, and then insert those into the database. Okay, now we also want to show how we can do some foreign key things. So I'm going to create a new table that connects customers to products, and as you might suspect, we'll create another table and we'll call this order. So this customer ordered this product. And because customers can order multiple products, and we hope to have multiple customers order the same product, we have a many-to-many relationship here. So this is actually going to be an associative table. Associate customers with products. And we're going to add some foreign key fields here. So first off, when we do an associative table, we often want to have the foreign keys that refer to the two tables or however many tables are being related. And we also want those two or those two or more foreign keys to be part of the primary key, a composite primary key for the table, so that we don't have multiple entries of the same customer buying the same product at the same time. So there's a little bit more to it, more to setting up this this configuration, but let's start out by creating a customer ID field. So this is going to be our foreign key to customer, and because the primary key in the customer table is an integer, we're going to leave that alone. We want this to be part of the primary key, so we'll click that, and then we're going to add another column that's going to refer to the product, so we'll call this product ID, and we want that to be part of the primary key. Except now we've got a problem here. You may have noticed here when I chose this to be the primary key that the primary key thing in the generated SQL down here switched from customer ID to product ID. Now if we have only one field in our table that we want to have be a primary key, that's entirely fine. But here we have a more complex case where we want to have both the customer ID and the product ID be part of the primary key, and we also want them to be foreign keys. So we can't just use this quick shortcut here. So I'm going to uncheck that, and you can see these have now gone back to being just ordinary fields that we'll enhance here in a second. Let's also put on here a quantity. So how many of these things did that customer order? We'll let that be an integer value. We'll make it not null. And we're going to put in a default value here just for yucks to say that, well, the customer by default bought one of those things. And you can see in the generated SQL down here that we get quantity as an integer. It's got a default of 1 and it's not a null value. And then finally we'll add another field that tells us the order date. So let's call this, well, order date. We actually want to have kind of the date and the time, and the field that we can use in Postgres for that is called a timestamp field. So we'll call that a timestamp, and that should be sufficient for this table. Now, we still haven't connected the customer ID and product ID as foreign keys to the other two tables that are going to connect these together, and we also haven't defined them to be primary keys. So let's go to this keys tab. Notice so far we have no keys. We're going to add a key, and we want to make a primary key. So let's check, and it gives us this order PK as the default name for this key. That's fine. We're going to make a primary key, and we're going to add some tables. So first of all, we're going to add customer ID. It gives us that for free. And then we're going to add product ID, which does autocomplete for us. And now we're good. We've got order PK, a new primary key that has both of these fields in it. Notice that down here now in the generated SQL, we have a new constraint called order PK, and then primary key, and the name of those two columns. We're no longer trying to set the particular primary key on a single column. As we saw before, SQL won't really let us do that if we specify the primary key constraint as part of the definition of the column. Instead, if we want to use those two together as the composite primary key, we enter what's called a table constraint that's not specific to one of these fields, but sort of stands on its own here as a unique constraint. We still need to define the foreign keys that refer to the customer and the product table. So we're going to go to the foreign keys tab and click the add button. It's going to give us a name for this foreign key that's going to get filled in for us as we fill out these different fields. So the first one we'll look at is the reference from the order to the customer. So the target table is going to be the customer table. And then what we need to do is specify the columns, the column in the table that we're going from, the order table, to the column in the table that we're going to, the customer table. So we're going to, in the order table, we're going to have this customer ID field, so that's already set. And on the other side, in the customer table itself, we want to refer to the customer's ID. Now you can see that as let me click out of this, you can see down here now in the generated SQL, let me make this a little bit bigger, that we can see the details of this foreign key that we've created. So on that customer ID column, we're creating a foreign key constraint that says that it's going to have this name, customer ID FK. It references the customer table, and in particular, it references the ID field within the customer table. It's also possible to define one of these foreign key constraints as a table constraint, similar to the way that we've defined the primary key constraint here. But in this case, it's not necessary because we're only connecting a single column in this table to a single column in the other table. Then we also want to add a foreign key to the product table. So product, and we'll add column specifier that says that our product ID in this table should refer to the ID field in the other table. And then we can hit execute. Now if we open up this drop down with the order, we can see we've got customer ID, product ID, quantity, and order date, and the appropriate foreign keys and primary keys are all set up. You'll recall that we had product IDs 1 through 3 and customer IDs 1 through 3, and because we've established foreign key constraints on our order table, those are going to be enforced when we try to add an order. So let's do that. Add an order. We'll add one that is going to use correct values for IDs. So let's say customer 1 ordered product 3 and bought 3 of them. And then on the order date, we can use this convenient picker that will let us choose a particular date and time, hit enter, and that fills in the value for us. And now we can insert that into the database. Okay, so that person bought that product. We can also demonstrate that if we use a bogus customer ID or product ID, that things aren't going to work properly. We know that that works okay, but let's use product ID 4, which doesn't exist, and we'll buy one of those things. And now if we try to insert that new row into the database, we should get an error. And we do. Error, insert or update on table order violates foreign key constraint, order product ID FK. That should look familiar to us because that's what we created when we added the table. So we can see that the database is doing the right thing. We can come back up here and say, no, we really meant to have product ID 2 being ordered. And now if we do the update, it will add successfully. Having created this little miniature database, we may want to share it with the rest of our team. And rather than having the rest of our team have to create it manually themselves, it'd be good for us to be able to supply them with a definition of not only the structure of the data, but also the test data that we've added, so we can all be sharing the same information. And the good way to do that is to use the revision control system. And in order to do that, we have to have some files that contain information about our tables and our data. And what we can do is use DataGrip to help create those things. So if I come here to my tables entry and right click, there's a couple of different ways I can do this. One simple one is to go to the SQL scripts menu item and choose generate DDL. DDL stands for data definition language, which is basically the create statements that will create these tables, to a query console. And we can see here that we get a whole bunch of SQL popping out that is pretty much the SQL that we saw already executed when we were working on creating these tables. So here's the definition of the customer table, the product table, and the order table. Now, there's also some additional information here that DataGrip has added for us that we didn't see before. For example, if not exists is additional syntax that tells the database, hey, create this table customer if it doesn't already exist. If it already exists, then we're just going to leave it alone. So it's a simple way to kind of do this on multiple occasions. If I've already got a customer table and then I try to recreate the customer table when I've already got one, it's going to cause a database error. So if I'm pretty confident that I already have that table, I might just put in this if not exists, and now I'll be able to run this thing multiple times. Something else that's put in here is the comment that we added to this particular table declaration. And then something that we might not want to include in our export of the database schema is this line that says, make the owner of this customer table be Tom, which is my default local database account name. If that's in there, it might cause some problems when your compadres on your team want to use this SQL in order to create their own or create their own database or update their existing database. So you might want to remove those alters to change the owner of the database. That way that the SQL, when it runs on a team member's machine, is going to just use their default user ID. So that's one way that you can do this. And what we'd want to do here then is just save this information to a file, usually with a .sql extension, like I would call it create schema.sql or something like that. And then we can use that file to check it into the revision control system so that the rest of our team can check that out and then create their own database using exactly the same database code. So that's one approach to doing this. A little more flexible one, again, if we right click on the table item in the hierarchy and go to that SQL scripts entry again and choose SQL Generator. This is a little bit more elaborate feature that's available inside of DataGrip that gives you a bunch of choices over here as to how you want to generate that output. And one of the things we can do here is simplify the notion of getting rid of that owner. So one of the checkboxes is ignore owner. So you notice here at line 27, I've got an alter table to add me as the owner of that table. But if I click ignore owner, it will regenerate this information to only have the create table and then the comment so that the owner isn't going to be changed at all. So that's another way to generate this SQL data definition output that will be something that you can use to share with your team. And if when you're satisfied that, you can click this Save into File button and then save it out as a .sql file. So that's how we could save or share the definition of our database. We also may want to share the contents of our test data. So after we've gone in and typed in this test data and typed in these products and these orders, it could be convenient for the rest of our team to have access to the same test data so that any kind of test code that we write will be able to be run in the same way by all of our team members. And we can do a similar kind of an export of these data into a file to allow team members to recreate it. So here in this order window, you can see here that there's a variety of different ways that we could export data. We could send it out as a comma-separated value, for example, to import into a spreadsheet, or tab-separated values and so forth. But what we want to do is actually create some SQL insert statements. So I'm going to leave that as it's already set, and then I'm going to do an export data. So I'm going to download, or I'm going to click that button, and I get this window that lets me see that I can export this as a list of insert statements that is going to add to the order table the particular values that I've already typed in this little spreadsheet view. So 133 and the stamp customer ID, order number, product or quantity, customer ID, product ID, quantity, and then the date stamp. So it creates that that SQL for me, and I can again do export to file, and then save this out to a file that I'm going to put into revision control so the rest of my team has access to this. And you could do this with all of the various information that you had keyed into your own database in order to make it easy to share with your end users. Here they've even supplied us with a default name for this export file, and they've by default it names it after the name of the table. So very handy way to share test data with your team. One final thing I wanted to show you here in DataGrip that you may not have been aware of, but that's the ability that DataGrip has to create an ERD for us. Again, if you right-click here on the table, it actually shows up in several of the context menus here in the hierarchy, and go down to Diagrams and choose Show Visualization. That will actually generate an ERD for us. So this is the information from the schema that we've created. We've got our customer table, our product table, and our order table, and it's going to show us the key fields, the individual attributes, the individual columns, and it also is going to connect the foreign key relationships. It's a little bit of a different syntax than what we're used to from the crow's feet notation that we've been using for ERDs, but it's the same basic idea. We're saying here that the arrow indicates the referenced table. So here we're saying that the customer ID references the ID field in the customer table. That's what this label means, which is basically just saying here's the foreign key, and it refers to the primary key on the other end of that relationship. So this is a really handy way of getting a nice diagram of the current state of your database. It's driven from the current contents of the list of tables that are there, and there's also some options that you can use up here to add or remove different pieces and parts and look at things in more or less detail and so forth. But you can experiment with that. You can also export this as an image, so if you're trying to write documentation or include it in a presentation, that's a really handy way to be able to show the structure of your database.